To explain the simple harmonic motion, we use the reference circle. What does it mean? We need try to understand, please. Reference circle. Reference circle. So reference circle means it is the representation of the diagrammic representation of the when the body is moving on the circumference of the circle. Just we are representing one of the body is moving on the circumference of the circle. Let's assume it is the x dash plane and y dash plane. This is the plane. So in this plane one body is moving on the circumference of the circle. Let's assume this is the circumference of the circle. So now how can you explain? Means this body is moving in the circular manner. So it is moving in the circular manner. So it is rotating about the fixed axis. Let me take this. The origin is O with the distance of radius of the circle with R. R is the radius of the circle. So it is rotating at a particular point. Now our goal is whether which position will be explained the simple harmonic motion. That's our goal. So our topic is the simple harmonic motion, SHM. So in this manner, by keeping on the view of simple harmonic motion, let me observe here one of the projection of the particle on the y-axis. Let me take this the projection of the particle on the y-axis. So this is the position of the particle and the position of the particle on the y-axis. So let me take this is the distance. Distance we will denote with the y. So now I am taking 4 different positions. Let me take if the particle is here, the projection will be somewhere here. This is at the center. So it is the point 1. So the point 1, the projection is the position of the projection of the position of the particle on y-axis is point 1. So if the particle is somewhere here near to this point, the position of the projection of the position of the particle is somewhere here. Like this. Now this is the point 3 and this is the point 3 and the location of the position of the projection of the particle also 3. Now if we take this is the point 4. Sorry, 2 na? This is the 2. So if I take the point 3, the position of the particle is here, then the position of the projection of the particle is here. So now it is also at the origin. Now if you go to the point 4, again the projection of the particle is same here. So like that it will go to the, again it will come to the point 5, means again it will complete the one complete rotation. Now we are taking only the position of the projection of the particle on the y-axis. Let me take this is the y dash axis. So at the point 1, the particle is at center O. So if you go to the at point 2, the projection of the particle is somewhere here. So if point 3, the position of the projection of the particle at the center only. If you go to the point 4, the projection of the particle is somewhere here. So if we come to the point 5, again the particle is coming here. It is nothing but the position of the projection of the particle is executing, is moving. See, at the center it is going up, again it is coming down, again it is going to the down, and again it is coming to the center. Like this is executing. That means if we observe the projection of the particle on y-axis, it is nothing but it is executing like a simple harmonic motion, because of it is moving it is moving in a straight line manner from its mean position in the to and fro motion. So that means and also one more thing. So the acceleration of the particle is directly proportional to the acceleration of the particle is directly proportional to the displacement of the. We will prove that one also. We are going to prove that one also. Then one more thing is there, the acceleration. So if the body is executing in a circular path, then the centripetal force will act towards to the center. That value we already know. That value is equal to A omega square. So sorry, that is R omega square. This is the centripetal force, centripetal acceleration of the particle, which will act towards to the center. Then this is the acceleration of the particle. If here the omega is equal to the particle, the omega is equal to angular angular velocity of the particle. So that means if a particle is executing in a circular path with angular velocity of omega, then the centripetal force which will act towards to the center, that value is equal to a r omega square. If you resolve this angular acceleration, now our goal is to discuss only along the y direction the projection of the particle. Now I am taking the acceleration along the y direction. Let me take the acceleration of the along the y direction, means this the total acceleration is equal to r omega square. So they are acting towards to the center. Now acceleration is equal to ay is equal to, tell me if it is the angle, the position of the particle is equal to, if the angle is equal to theta. Now resolve along the with help of the vectorial resolution. So this is the position, this value is equal to a is equal to r omega square. So the angle of this vector with x-axis is equal to theta. Now our goal is to find out the y component. This is the y component of the acceleration. Now we take this one. It is nothing but a total vector of the a into sine theta. That is the formula. So the total acceleration is equal to r omega square sine theta. This is the formula we are having. So this is the resolution of the vector, the component of, we are resolving the vector into x component as well as the y component. If you want to know the x component also, ax is equal to a into cos theta will come. So this component is equal to ax is equal to a into cos theta. These value we are not concentrating about this value because of the execution of the simple harmonic motion is having only along the y direction. The position of the particle is executing along the only y direction. That's why we are concentrating only along the y direction component ay value. So now if you take this value, we are not discussing the ax and ay. That's why I am taking this one. We are not, if you take this one, just I am taking, remove this a value, this is nothing but r omega square. Just simply I am keeping a is equal to r omega square sin theta. So this is the total acceleration of the body. This is the component of the acceleration of the body along the y direction. Now with help of this one, let me, this is the y value, this is the r radius value. Now I am taking only, this is the r value, this is the radius of the value. Just I am taking, this is the y value. So this y value means this is also y value. Can you take the sin theta with the help of the diagram? Sin theta is equal to, let me draw the diagram. So this is the r value, radius of the vector, radius of the circle. This is the position of the particle y along the y component. It is the angle theta. So sin theta is equal to opposite side by hypotenuse. Then now I am substituting sin theta is equal to y by r. So that is equal to r omega squares. Instead of sin theta I am substituting y by r. Now r and r square, r I am removing, that is equal to omega square into y I am getting. So these, please keep it in our mind. We are discussing the acceleration of the particle along y direction only because of the particle is executing only the simple harmonic motions along y axis only. That is our goal. So now will you please look on this one? So the acceleration is acting in downward direction, but the displacement is moving in upward direction. That means if we take these values will tell us that only magnitude. So these values are telling that only magnitude. If we include the direction also, if we include the direction also, how can we include? So then a is equal to minus omega square y, because of acceleration is acting towards to the center, but displacement is moving from above from the center. So the displacement is moving away from the center, but acceleration is acting towards to the center. They are in the opposite direction. Because of this is the total acceleration direction, but we took the only y component acceleration. It will look like this. This is the resolution of the acceleration a omega square y value. This is the acceleration of the acceleration value of the component along y direction. So will you please look on this one. The direction of the acceleration is always an opposite to the direction of the displacement of the particle. So then what we can say, so the position of the particle along the y-axis is nothing but it is completing the condition of the simple harmonic motions. What is the condition? What are the conditions for the simple harmonic motion? What are the conditions? There are the three conditions are there. One condition is that the particle should execute the straight line motion, to and fro motion, straight line to and fro motion from its mean position. So that is the first condition. What is the other condition? So the acceleration is always directly proportional to the displacement of the particle. What is the third condition? So the acceleration is the direction of the acceleration is always to the opposite to the direction of the displacement of the particle. So that is the first condition is it should be in the straight line path motion. The second condition is it must be to and fro motion from its mean position. The third condition is the acceleration is directly proportional to the displacement of the particle. The fourth condition is the acceleration direction is always to the opposite to the direction of the displacement of the particle. Will you please look on this one? All conditions are obeying the position of the particle in the y-axis. So will you please look on this one? It is moving. If you take the position of the particle in the x-axis, there it is moving in the straight line motion only, straight line path only. First condition is obeyed. The second condition is it is moving to and fro motion from its mean position. From this is the, if you take this is the mean position, so it is moving to and fro motion, so it is moving, the second condition is obeyed. So if you take the third condition, so will you please, just now we derived this equation. So this acceleration is directly proportional to the displacement of the particle with some constant. So the third condition also obeyed. So will you please look on this one. It is the acceleration direction is the upward, it is the displacement direction is the upward direction, but the acceleration direction is the downward direction. Always there is the opposite in direction. That's why acceleration is equal to minus omega square v2. So all conditions are obeyed. Then we can say that the position of the particle in y-axis it will execute a simple harmonic motion. So that is our explanation. What does that mean, reference line? So the reference circle is nothing but it is a representation of the particle which is moving in a circular path for a particular radius, which is moving with a constant angular velocity omega, with a constant angular velocity of omega on the circumference of the circle. That representation is named as the reference circle. They won't ask in your examination. Reference circle is not included in your syllabus. Just we discuss. With help of the reference circle only, we are going to discuss each and every component, each and every physical quantity in the simple harmonic motion. Let me move on to the another concept. So now if we draw the reference circle like this, reference circle is nothing but it is a diagrammatic representation of the when the particle is moving in the circumference of the circle with having the constant radius r and also in anti-clockwise direction. Let me take in the anti-clockwise direction with angular velocity of the omega. So let me take the position of the particle at a given instant at point P. So we are moving to the another concept. Please concentrate here. So the position of the particle at a given instant is P. So if you take the projection of the particle on the y-axis is let me take from its mean position is the y. Let me take the y. So the angle made by the position vector of the particle with x-axis is equal. Let me take the theta. Theta is the angle made by the position vector of the particle with x-axis. Let me take this the x-axis, this is the y-axis like this. Now will you please look on this one. If it is the y, now I am drawing the one small triangle here. So let me take OPM. So will you please, with help of these triangle, our goal is to find out the displacement of the particle. This is the displacement of the particle from y. Can you please look on this one? Can you with the help of the, if you take the sin theta is equal to opposite side PM, opposite side by PM divided by hypotenuse OP. So hypotenuse OP is nothing but it is the radius of the circle. So that is the radius of the circle R. So the PM is nothing but it is the displacement of the displacement of the particle from its mean position Y, where Y is equal to R sin theta. This is the equation for the displacement of the particle in simple harmonic motion. So how can we define this one? So the simple harmonic motion. Let me introduce one more component here. So if we are very familiar with the velocity, linear velocity of the particle. Velocity is equal to displacement of the particle divided by time. This is the formula for the linear velocity of the particle. So in the particular case, what we took, the particle is executing with omega angular velocity in anti-clockwise direction. How can we define angular velocity? So the angular velocity of the particle is equal to angular displacement, angular displacement by time. So angular displacement is nothing but angular displacement. It is nothing but theta only. It is the angle only. So the angle by time. So the angular velocity in the particular case, our running content omega is equal to, we can take the theta by t. So from this equation, the theta can be written as omega into t. So this is the formula, omega theta is equal to angle is equal to angular velocity into time. So will you please look on this formula? So the displacement of the particle in the simple harmonic motion is equal to R sin theta is there. In this equation we can put like this, Y is equal to R sin omega t. This is also another expression for the displacement of the particle, where the particle is executing simple harmonic motion. So now what is the definition for the displacement of the particle in SHM? Will you please look on this diagram? The particle is displaced. It is nothing but Y is nothing but we took that displacement of the particle. So will you please look on this one? It is the distance from the main position of the particle. So from this main position, how much distance is there? That distance only we are discussing up to now. So that means the displacement is nothing but the distance of the vibrating particle from its mean position at any instant, at any given time, is nothing but displacement of the particle in the SHM. Let me write the definition for this one. So the displacement is nothing but, very important one, displacement in nothing but in SHM only. We are discussing all parameters in the SHM. So that in SHM means a simple harmonic motion. So how can we define the distance of the vibrating particle? So vibrating particle, the distance of the vibrating particle from its mean position, at any instant is called displacement of the particle. So displacement of the particle. So displacement of the particle. So for your easy understand, let me take one more example. I already told you, if the angle of displacement is very small, the simple pendulum can execute the SHM oscillations. Now I am taking the one simple pendulum like this. I am taking the very small angle like this. This bob is executing the simple harmonic motion from its mean position. So now will you please look on this one? So this is the distance. This is the distance from its mean position is named as the distance from its mean position is named as the displacement of the particle Y. The same parameter also we are discussed here, also same thing only. So will you please look on this one? This is the same thing only. So the particle, this is the displacement of the particle. The distance of the particle from its mean position when the particle is vibrating from its mean position at any given instant. At any given instant means the particle can have at this position somewhere here. The particle will have somewhere here. The particle will have somewhere here. at that position the distance we need to take, and this position the distance is this one, displacement is this one, this position the displacement is this one, this position the displacement is this one, like this we need to know. So that is the definition for this one. So let me read once again. The distance of the vibrating particle from its mean position at any instant is called the displacement of the particle. So that is the definition for the simple harmonic motion displacement. Let me take the special cases for the displacement. So is there any issue? Somebody give a name to me. Is there any issue? Hello?
Sir, displacement definition of such a person.
Okay, wait. Okay. No issue. Okay, let me. So one more time, displacement. What is the displacement? So displacement is nothing but it is the distance of the vibrating particle from its mean position. Mean position means I already told you mean position is nothing but it is the position where the total resultant force of the particle must be 0. So here is the particle is the mean position. Now that means from the mean position how much distance the vibrating particle is there. That distance is named as the displacement of the particle in the SHM. So that means at a given instant means so that we are doing the experiment means at a particular time if this is the time t is equal to 0 second, the particle may be here with 1 second, the particle may be somewhere here 2 seconds, the particle may be somewhere here 3 seconds, like that. At given instant means at the given time how much distance is there from its mean position, that is the named as the displacement of the particle in SHM. In the same manner, if you go to the above diagram also, will you please look on this one? So the particle is moving like this. At any instant, some particle may be here, the particle may be here, the particle may be here, the particle may be somewhere. So at given time where the particle is there, what is the distance of the particle from its mean position, that is named as the displacement of the particle. Now we are moving to the special cases.
Thank you, sir.
Okay, we are moving to the special cases. So the special cases means let me take what I took. So in the previous case what I took means so I took the particle is at a given instant the particle is here somewhere here. So the angle I told is the theta of the angle of the particle at given instant, but it may not happen for all times. Because of it is not happen to the all times. Let me take one special case. If the particle is at a given instant at the starting stage, the particle is here. That means we are running our clock with time is equal to 0 seconds. We started here. The particle is here. That means in the starting stage also the particle is having some angle. Let me take that angle is the pi. Pi is the angle of the particle which is made by the position of the particle with x-axis. After given interval of time, that means after time t is equal to t seconds, the particle is somewhere here. That is the t is equal to. So what is the angle made? So the angle will be calculated with the instant with the starting position to the next position we need to measure. So it is the angle made by the particle from the starting stage of t is equal to 0 second to t is equal to t second. It is the theta of the angle made by the particle from its initial state to final state. Then our goal is what I told you. What is the distance of the particle? This is the distance of the particle at a given instant. This value we need to find out, y value. But to draw this one we need to construct the diagram. This is the construction of the diagram. So will you please look on this one. This line is making angle. This is the angle is making from its x-axis. So this is to draw this one, to apply the trigonometric rule. We constructed a perpendicular one right angle triangle which is having the angle. This angle is equal to the angle of sum of the pi as well as the theta. So this angle is equal to pi as well as the theta. So let me draw once again this separate angle. So this is the like this triangle is there. This theta is equal to, so theta as well as the pi. We having the sum of the two angles. Now our goal is to find out the displacement of the particle. So can we apply the trigonometric rule? Sine of, now let me take this theta plus omega, theta plus pi is equal to, what is the opposite side? Opposite side value, this value, that is nothing but y value only, y divided by hypotenuse. Hypotenuse is equal to radius. Let me take radius is the constant r, y by r. So then y is equal to r into sine of theta plus pi. Already we know that one. That one theta is equal to omega into pi. Then r is equal to sine of omega t plus pi. This is the equation. Will you please look on this one? So that means at the given, see, at the initial state, the particle is having some of the angle with the x-axis. This is the case. This is the case at the initial state, the particle is having some of the initial angle, that is the width of the pi angle. It is named as the phase. We will come to that picture also. Let me take the initial angle. The particle is making the positive angle. At initial state, if the particle is having the positive angle, we need to use this formula, displacement of the particle. This formula we need to use. Now we are going to the other special case. Let me take what is there. So if the particle is not having the positive angle, let me take our clock is running t is equal to 0 seconds. Then the particle is somewhere here. This is the somewhere the particle is having. So with the x-axis, the particle is making the angle with the initial angle pi. Pi is the initial angle of the pi. Will you please look on this one? Our measurement says the particle is moving with anti-clockwise direction, and also angle should be made with positive angles. Only in anti-clockwise direction only we need to measure. But to measure this angle, we need to count down. Like this, we need to count down. That means this angle is the negative angle. This is the negative angle we are having. So after a particular instant of time, that means after clock is running, the particle is moving somewhere here. The particle is moved somewhere here. So that means what is the angle made with this one? We need to, all angles we need to measure from its initial position. This is the angle made with from its mean position with the theta. Theta is the angle made with the initial position. Now our goal is to find out the displacement of the particle. So this is the displacement of the particle from its mean position y value with 0. O is the initial position of the particle. We need to find out this value. So to draw this one, we need to try a right angle triangle OPM. So OPM, this is the angle of the triangle. Will you please look on this one? This angle we don't know. Will you please look on this one? This total angle is the theta, the small angle is the pi. What about this angle? What about this angle?
Theta minus pi.
This is nothing but theta minus pi value. So can we apply the sin theta formula in this one? Sin theta is equal to what is the sin theta not. Can we apply sin of theta minus pi is equal to what is the one in this one? Opposite side. Opposite side y value divided by hypotenuse value r value. So opposite side y value divided by hypotenuse value r value. Then y is equal to r of sine of theta minus pi. This is the formula. But we know this one theta is nothing but omega into t. Then sine of omega t minus pi. This is also displacement formula only. But what is the condition here? At the initial state, the particle, yes, at the initial state, the particle is having the negative angle. So the particle having the negative initial angle, then we need to use this formula. This formula we need to use at the initial state, the particle having the positive angle. This formula we need to use. What about this formula? What about where it is? So where it is? Somewhere in top, I hope. So where it is, so this formula we need to use, where it is, this formula. So at the initial stage, the particle does not having any angle with the x-axis. This formula we need to use. Are you getting or not? Hello?
Yes.
So that is the formula we need to use. These are the special cases for to apply to find out the displacement of the particle. Now we are move on to the displacement. In the kinematics, if you know the displacement, can you find out the velocity in the kinematics? Normal kinematics. What is the definition for velocity in the normal kinematics? Let me apply one more thing here. let me apply one more thing here. What is the, let me draw the diagram. So this is the, wait, please, one more time. Before dealing the velocity, we need to take the some more cases are there. So this is the particle. It is the particle. Where is the radius of the r? The angular velocity of the particle is omega in the anticlockwise direction. So in this case, that angle of the theta is equal to theta. In this case, the displacement of the particle y is equal to r sin omega t. This is the formula. Otherwise, we can write simply r sin theta. This is the formula. Now our goal is where the particle having the maximum displacement, where the particle having the minimum displacement. That condition we need to understand. So if we look on this one, if the particle is here, if the particle is near to this place, then the particle, if the particle is near to this place, the particle will have the maximum displacement. Are you getting or not? Hello?
Yes, sir.
So if particle is here means what about this angle? So we are moving. So if it is here means 0. If we are moving here means up to this place means what is this angle? This is nothing but 90 degrees only, no? Hello? 90 degrees only. Then, so that means the maximum displacement will have, y will be having the maximum value. Where the maximum value? Maximum value after theta is equal to 90 degrees. What is that maximum value? Maximum displacement value. Put the theta is equal to 90 degrees in this one. So r sin theta is equal to 90 degrees is equal to r only. That means the maximum displacement of the particle, where the particle is moving in the circumference of the circle, the displacement of the maximum displacement of the particle y is equal to r. Y maximum is equal to r. Now, what is the minimum displacement of the particle from its mean position? Minimum.
Yes,
So the minimum means minimum means the particle must be, the displacement nothing will be. So that means y must be 0. Where y must be 0? If the particle must be here or somewhere here. So if this place or this place, the particle must be the particle must be available in this 1 and 3 position. Will you please look on this one? If the particle is 1 and 3 position, the theta values. What is the theta values? Will you please? If the first case for the minimum position, the theta value at theta is equal to 0. If this place is equal to theta is equal to 0, this is correct only. What about this place? If we go to up to here, what about this angle? It is the straight line. Straight line angle theta value is equal to 180 degrees. 180 degrees only, na?
Yes, sir.
So that is the case. So that means the minimum displacement will be available in the simple harmonic motion of the projection of the particle in the, where the particle is moving in the circumference of the circle at theta is equal to 0 as well as the theta is equal to 180 degrees. What is the minimum value? What is the minimum displacement value? 0. This is the minimum displacement of the value is equal to 0. So this is the maximum displacement of the particle. It is the minimum displacement of the particle at theta is equal to 180 degrees. Now we are moving on to, is there any issue regarding this?
Sir, minus r is equal to 0 Sir, minus r
No. Minus r is not having. So not if you go to here 273 degrees centigrade. 273 means that displacement will give the minus. Yes, you are telling that what is the maximum value means minus r. So the displacement. What is the displacement? We are measuring all values from its mean position. We are measuring all values from the mean position. So it may be theta is equal to 90 degrees, r is equal to y maximum is equal to r. If theta is equal, let me take here also. Another case we will take y maximum at theta is equal to 270 degrees, 220 degrees. Then y maximum is equal to r sin 270 is equal to minus r. This is also maximum value. If we take the only magnitude, y maximum value only we will get the r value only. Magnitude means without, yes please.
y minimum లో సార్ theta equals to 180 ప్లేస్ లో sin ప్లేస్ లో పెడితే మైనస్ r వస్తుందా సార్?
No. Let me do that. No, you trigonometric rules are, you are not recalling trigonometric accurately. So y minimum is equal to what is the formula? R into sine of theta. You are telling that instead of theta we need to put the sine of 180 degrees. 180 degrees means R of sine of 90 plus 90. So sine of 90 plus 90 is equal to what is the value? Cos 90. So that is equal to R cos 90. R cos 90. Cos 90 is equal to 0. 0 only. 0.
Yes, sir.
Okay, 0 only. So that is the
Thank you,
case.
sir.
Okay, no issue. Now we are moving to the another one. So if will you please look on this one at a particular case, the displacement of the particle is getting the maximum value. So that maximum displacement can be used another terminology. That word is named as the amplitude of the particle. So amplitude, it is nothing but y maximum only. What is this one? What is meant by y maximum? So the maximum displacement of the vibrating particle from its mean position is named as the amplitude of the particle. Let me write that one. So the maximum displacement of the vibrating particle from its mean position is called amplitude. So that means what is the amplitude of the particle in our case? What we are discussing in our case, what is the amplitude? So the amplitude will denoted with the special y maximum only. In our case, what is the amplitude of the particle? Only we are taking the amplitude only in the magnitude of y maximum. So the amplitude y maximum is equal to R only. Because of in our case the particle maximum displacement will having this value. This is equal to R only. This is also R only. So if you take only magnitude only we are discussing,
Yes,
y maximum is equal to R. This is the amplitude of the particle. So that is the one. Let me move on to the another quantities which you need to understand in the simple harmonic motion. If in the kinematics, if you know the displacement, we can find out the velocity. Velocity in the kinematics is nothing but time rate of change in displacement. Time rate of change in displacement. So this is the kinematic definition. So the time rate of change in displacement in mathematical expression, if you take the displacement is S is the displacement. Let me take S is the displacement. How can you write velocity in the kinematics? ds by dt. This is the formula for the velocity. In the simple harmonic motion also the same formula we will use. So let me take the velocity of the particle in the simple harmonic motion. D in our case, whatever using the displacement, we are using the displacement y term dy by dt. We need to use this formula. Now if we substitute what is the y value, we know the y value is equal to R sin omega t. This is the formula we are having. It is the displacement formula. So in this case we are taking the first case because of the initial stage the particle does not having any angle from its x-axis. That case we are taking. Special case we are not considering here. So that is equal to
theta.
Here you are asking here, yes, we can put the theta also. You are saying y is equal to R sin theta, no? You are saying that. So don't use that formula because of we are derivating this equation with respect to the time. If you keep the theta means you feel that there is no any time dependent parameters in this equation. Then you will simply say that dy by dt is equal to 0. You may get confused, no? That's why I written here theta is equal to omega t because of the derivative, the dependent parameter is a theta, t term is there. That's why I written in terms of t. So dy by dt where y is equal to R sin omega t. So in this one R is the constant, we will keep outside R into d by dt of sin omega t we will get. So we know the formula d by dx of sin of ax is equal to what is the formula? Cos ax into d by dx of ax. That is nothing but cos ax into a. This is the formula we are having. So with help of this formula, so here what is the formula? Instead of A we are having omega, that's why R into cos of omega t into omega. This is the formula we are having. So send this omega this side. So R omega into cos omega t we are having. So you know the formula, sin square theta plus cos square theta is equal to 1. We have the formula. So we in this one omega t is equal to theta only. We have the cos square theta is equal to 1 minus sin square theta we will get, where cos theta is equal to square root of 1 minus sin square theta. We have the formula. Now instead of theta is equal to omega t only, instead of cos omega t, can I write like this? R omega is equal to 1 minus sin square omega t. We will put like this. Is there no issue now? Hello?
No, sir.
No. So we already know this one. Omega t is nothing but theta only. So omega t is nothing but theta only. R omega into 1 minus sin square theta. So with help of the diagram, will you please look on the diagram? So what sin theta is equal to, will you please look on this diagram? So this is the angle where the radius of the R, it is the theta with the theta, where sin theta is equal to, this is the displacement of the particle y, where sin theta is equal to opposite side y divided by hypotenuse R. So where sin theta is there, we can write y by R, where sin square theta means y square by R square only. Hello?
Yes, sir.
So sin square by R square, sin square theta is equal to y square by R square only. So can I put like this, R omega divided by 1 minus y square by R square. So in this root equation, I am taking the R outside. Then R omega is equal to R. I am taking the LCR, that is equal to R square minus omega square. So again divided by R square. So I am taking the roots in the separate roots, that is equal to R omega into square root of R square minus omega square divided by root R square. We get root of A by B is equal to
y square, sir.
y square. Yes. Here is the y square. So y square. Here is the y square. Sorry. So here is the y square. So now root of A by B is equal to root A divided by root B we can take. So root of R square is equal to, we will get R will cancel. That is equal to omega into R square minus y square. This is the formula for the velocity of the particle in the SHM motion. Where the particle, where omega is equal to angular velocity of the particle, where R is equal to radius of the particle in the circle, reference circle, y is equal to displacement of the particle in the reference circle. In this case also we are moving for the special cases. So let me write this equation separately. So we are moving to the special cases where the velocity will be maximum. Special cases. So now we know that what is the formula? Velocity formula is equal to omega square root of R square minus omega R square minus y square. So our goal is V maximum point we need to identify. That is the first condition, V maximum, where V will be maximum. So this part will be maximum means we need to remove this part. So if this part is removed, then V will be maximum. So where this part will be removed, Y should be 0. That means so if Y is equal to 0, that is equal to V is equal to omega into R square minus 0 square, that is equal to R root of R square will get, that is equal to R omega will get. This is equal to V maximum value. The maximum velocity of the particle in SHM motion, if the particle is moving in the circumference of the circle, then the maximum velocity formula is equal to R omega. This is the formula for the maximum velocity of the particle. Let me move on to the where the maximum velocity will be minimum. So the second case will be velocity will be minimum. That question we are taking. Let me write the formula. Velocity V is equal to omega into square root of R square minus omega square is there. So where should be minimum value means the minimum value is nothing but 0 only. 0 velocity only. Where it will be become 0? Sorry, y. So the y will be equal to the R, then R square minus R square will be 0. R square minus R square will be 0. Then V value will be 0. Then how it will become if y is equal to R, that is That is, what is that one? Y maximum. Y maximum is equal to R only, na? That is equal to Y maximum. Y is equal to Y maximum. Y is equal to Y maximum. Then what will happen? Then V minimum velocity is equal to 0. V minimum velocity is equal to 0. Let me put this value, just substitution only. V is equal to omega into square root of R square minus R square only. Just instead of I substituted Y maximum. Y maximum value is nothing but R only. So R square minus R square, that is equal to omega into 0. Then it is equal to 0. This is the minimum velocity of the particle. Where the particle is minimum velocity? Where the particle is having minimum velocity at the maximum displacement position. Yeah, at the maximum displacement position, the particle is having the minimum velocity at minimum displacement position. Will you please look on this one? Y is equal to 0 means a minimum displacement position. Will you please look on this one? Y is equal to 0 means at minimum displacement position. At minimum displacement position. So at minimum displacement position, velocity of the particle is maximum. If you go to the downward, so Y maximum means at maximum displacement position, velocity of the particle is minimum. So this means at maximum displacement position, at maximum displacement position. At maximum displacement position, velocity of the particle is minimum. At minimum displacement position, velocity of the particle is maximum. You can easily understand with help of the simple harmonic motion which is executing by the simple pendulum. Will you please take this simple pendulum? Let me take this the mean position of the pendulum. So with a small angle, we are vibrated with this simple pendulum. So this pendulum is executing the simple harmonic motion. Let me move on. This is the straight line only. So this particle, what is the maximum displacement position? So up to this point only the pendulum is coming. This is the maximum displacement position. Whether this point is the velocity is the 0 point or not. Let me check for this one. So how it will be 0? See, the particle will move like this up to this direction. The velocity of the particle is like this direction. After reaching this maximum point, the particle is moving, changing its direction. Another direction the particle is moving. That means at a maximum point, the velocity of the particle must be 0. Are you getting that? Hello?
Yes, sir.
Will you please once again, I am repeating this one. Check this one. See, the particle is moving from its mean position. The direction of the velocity at this, when the particle is moving towards the maximum position like this direction towards the right. So, but when the particle is coming from the maximum position to the mean position, the velocity of the particle is towards the left. But what my conclusion is, at the maximum point of at the maximum displacement point, the velocity of the particle must be 0 because of the direction of the velocity is moving from left to right. Again, it is changing to the right to left. So that means it is a turning point. At the turning point position, that is the maximum displacement position, velocity of the particle must be 0. See, if you go to this side also, see in this side the particle is moving from left to right. The velocity of the particle is in the left to right is there. Sorry, right to left is there. So after reaching the maximum position, what is the velocity of the particle? If the particle is coming from maximum displacement point to mean position, it is from the left to right is coming. That means at this maximum displacement point, velocity of the particle must be 0. That is the position of the particle. This position, the velocity of the particle must be 0. So that is the case we are taking. So will you please look on this one? If this point, will you please in the simple pendulum also, you can easily observe. In your childhood, you use the cradle. Means when the cradle is moving, crossing the mean position means it will move with the maximum velocity. When the cradle is changing its direction means the velocity of the cradle will be 0. At this point, the velocity of the particle must be 0. But this point, when the cradle is crossing the mean position, at that point the velocity of the particle must be maximum. Are you getting that or not? So, what is mean by cradle? ఊయలా? ఏమా అర్థమవుతుందా లేదా నేను చెప్పేది? హలో
క్రాడిలెన్స్
ఊయలమ్మా, ఊగేటువంటి ఊయల లాస్ట్
అనేది v మాక్సిమం అనేది 0 అయినప్పుడు మళ్ళీ వెలాసిటీతో మళ్ళీ బ్యాక్ కి ఎందుకు రావాలి సార్? అక్కడే ఉండొచ్చు కదా?
No, don't. See what I told you. So the particle always will be stay at mean position itself. It is not a equilibrium position. In this case, the total force which is acting in this point is not equal to 0. The particle will be rest if the net force is acting is 0. In this case, the tension is upward direction. So that the bottom weight is acting downward direction. Both is balanced. That way the particle is here. But in this case, the total net force is acting on the body is not equal to 0. That's why the resulting force will act towards the mean position. Resulting force always act towards the mean position. That's why the particle will always tries to come to mean position. అంటే చివరిలో ఉన్నటువంటి పొజిషన్ దగ్గర నెట్ ఫోర్స్ అనేది ఎప్పటికీ కూడా జీరోగా ఉండదు, గుర్తుపెట్టుకోండి. ఎందుకంటే మీన్ పొజిషన్ లో మాత్రమే జీరో ఉంటుంది, బట్ లాస్ట్ లో ఉన్నటువంటి పొజిషన్ లో దగ్గర ఎక్కడ దానికి జీరో ఉండదు. ఒకవేళ ఇక్కడ ఎందుకు జీరో ఉండదు అనేటువంటి ఒకసారి మనం కంప్లీట్ గా నెక్స్ట్ క్లాస్ లో వస్తుంది అనుకుంటా. దీనికి మొత్తం ఇక్కడ ఉన్నటువంటి ఫోర్స్ వెయిట్ ని మనం తీసుకొని, అలాగే దీని మీద పడుతున్నటువంటి టెన్షన్ తీసుకొని రిజల్టెంట్ ఫోర్స్ మనం బ్యాలెన్స్ చేసినట్లయితే డ్రా హియర్ ఆల్సో ఇక్కడే రాద్దాం ఉండండి, ఒక చిన్న టైం వేస్ట్ అవుతుంది. we need to do, let me try to mean position. So now here this is the at extreme position దగ్గర ఉన్నటువంటి చూసుకోండి. So the mass of the body is m, the weight will act in downward direction mg అనేటువంటి weight యాక్ట్ అవుతుంది. Let's see the tension of the body, tension యాక్ట్ అయినటువంటి tension on the body. But if you want to this is the angle made with one, చూడండి ఇది మనం యాంగిల్ ఇలా ఉందనుకోండి, this is the angle, ఇది ఒక యాంగిల్ అనుకోండి, let me take, otherwise take this angle theta, ఇది ఒక theta అనుకోండి, let me take for your easy understanding I am taking the theta. Now this t is resolved in the two components, రెండు components గా నేను రిజాల్వ్ చేస్తున్నాను. in upward direction is equal to, so in this direction, ఈ డైరెక్షన్ లో కావాలంటే ఏం తీసుకోవాలి, t sin theta అవుతుంది. t sin theta. So what about the t value in the horizontal direction లో t cos theta. Will you please look on this one? t sin theta is balanced by the maximum weight of the body. t sin theta వల్ల maximum weight తో balance అయిపోయింది, these two are cancelled. But t cos theta is not balanced by the any other force. ఈ ఫోర్స్ తో ఏది బ్యాలెన్స్ కాలేదు, ఈ సైడ్ ఏ ఫోర్స్ పనిచేయడం లేదు, గుర్తుపెట్టుకోండి. That means due to this force the particle will always come towards the mean position వైపుకే వస్తూ ఉంటుంది. ఓకేనా, అర్థమవుతుందా? ఒకవేళ ఇక్కడికి పోతే పరిస్థితి ఏంటంటే నువ్వు ట్రై చేయి, ఇటు సైడ్ డయాగ్రామ్ వేసి నువ్వు ట్రై చేయి, ఇటుపక్క కూడా సేమ్ పొజిషన్ లో ఉంటుంది, ఇటుపక్క కూడా ఫోర్స్ అనేది ఇలాగే పనిచేస్తుంది. ఏమ్మా, హలో? Okay, done. Let me go to move on to this one. So now what our conclusion? A conclusion means we concluded two conditions. One is the at maximum displacement position the velocity of the particle is 0. At minimum displacement position the velocity of the simple harmonic motion particle is maximum. That value is equal to r omega. Now let me move on to another one, acceleration of the particle. Acceleration. So in the kinematics, what is the acceleration definition? In the kinematics, acceleration is nothing but it is the time rate of change in velocity. That's all, enough. So the time rate of change in velocity. So the time rate of change in velocity is nothing but it is acceleration only. So what is the mathematical expression in the kinematics? So acceleration A is equal to dv by dt. But in our case, what is the velocity? Our case formula? Velocity is equal to r omega into 1 minus sine square omega t. This is the formula we are having. Otherwise our previous formula v is equal to, what is the formula? R omega into cos omega t we are having the formula. Are you getting or not? Hello? This formula only, na?
Yes, sir.
Will you please go into the top? Let me check.
Yes, sir.
If you are writing the running notes means you can easily understand. If you are not following the running notes, then you will get to see this is the velocity only, na? With help of this topic, just we converted all equations. This is the velocity formula. So this is the r omega sin omega t. This is the formula. Now this is the velocity. What about the acceleration? Where acceleration a is equal to d by dt of r omega into cos omega t. This is the formula. In this one, r is the radius of the circle. Omega is equal to angular velocity of the particle. These are the constant. We will take it out these two values, r omega into d by dt of cos omega t. So you are already well familiar with this equation. d by dx of cos ax is equal to, so that is equal to minus sin ax into a only. Minus sin ax into a only. So that is equal, here is the instead of a we are having the omega here. Then can you write like this? So now this is equal to r omega into minus sin omega t into omega only. This is the formula. Now this omega and this omega will become omega square, r omega square, negative sign I am writing here, negative r omega square into sin omega t. Will you please look on this one, r omega square, where sin omega t is nothing but theta only, sin theta. Omega t is equal to nothing but theta only, sin theta. So one more condition I am taking here. So sin theta is equal to, in the diagram, sin theta is equal, anybody will tell the diagram for sin theta is equal to y by r only. Pi by r only, sin theta is equal to. Are you getting that, ma'am? Hello?
Yes, sir.
Sin theta is equal, substitute this in this equation, just substitute in this equation, minus r omega square into y by r cancelled, then a is equal to minus omega square y only. So if you remove, this is the omega square is the constant term, with this help of this one, a is directly proportional to the negative value of the displacement of the particle. Negative value of the displacement of the particle. Now this is the just conclusion only we used. Now we stopped here. A acceleration of the particle is equal to this formula. We are going to use this one. Now let me use this one where the particle we having. Otherwise we will take this one and this one. Any equation we will use. Let me write two equations here. So for the special case we are taking, so we have the two equation where a is equal to, let me take negative sign, this equation only, minus omega square y value. This formula we took. So now our goal is to find out the a maximum value. How can we get a maximum value? If omega is the constant angular velocity of the particle, it won't changes, but the changing parameter is only y value only. If y is the maximum, a will be maximum. Where it will maximum? That is equal to a maximum is equal to minus omega square into y maximum value. So what is the y maximum value? Just now we discussed. Y maximum value is equal to r only. Y maximum is equal to r only. The a maximum acceleration of the particle at maximum acceleration of the particle is equal to minus omega square r only. What is the minimum value? A minimum. How can you find out? From the formula a is equal to minus omega square y. Where it will be minimum? If y is equal to y minimum, that is equal to 0, then a will become minimum. A minimum is equal to minus omega square into 0, that is equal to 0. That means at the maximum displacement point, the particle having the maximum acceleration, at minimum displacement point, the particle having the minimum acceleration value. Will you please look on this one? So in the previous case where we discussed, so will you please this one? So this place, now I am taking, this is the maximum displacement point, other color. So this is the maximum displacement point, that means here is the a maximum will be. So it is the minimum displacement point, this value having the a minimum point only. Are you getting that? Hello?
Yes, sir.
So will you please check this one. So where it is? See this one. At maximum displacement point, a maximum will come. At minimum displacement point, a minimum will get. So maximum displacement point means the particle should move from its mean position maximum distance. It is the maximum distance point only. This is the a maximum point. The at minimum displacement point means the particle should not have any displacement from its mean position. That means the particle will have at the same minimum position only. So mean position only. This is the a minimum point. This is the a minimum point. It is the a maximum point. This one. So now it is from in this one. This is the simple. Yes. So let me
velocity के opposite का उनके का sir.
Yes. That one also I will conclude. Let me conclude. Let me please wait one more time. So let me see if this one in this our case means the particle is executing. The particle is moving in the circumference of the circle. So the maximum displacement point means here is the maximum displacement point here. So these 2 points are the maximum displacement points. Where the minimum displacement points? These 2 points are the minimum displacement points. These 2 points are the minimum displacement points. So if you take 1, 2, 3, 4 means 2 and 4 are the maximum displacement points. 3 and 1 are the minimum displacement points. Now let me check on this one from this equation. What this equation is telling? Let me here only I told you. This is the conclusion. What is the conclusion? The acceleration of the particle is directly proportional to the displacement of the particle. And one more condition is saying that the acceleration, the direction of the acceleration is always opposite to the direction of the displacement of the particle. The negative sign is indicating that the direction of the acceleration of the particle is always opposite to the direction of the displacement of the particle. That means what is the direction of the displacement? Will you please look on this? Now we are going to here. So if this one I already told you, the force will act in this direction. The force is acting in this direction means force is equal to ma. So if the force direction, accelerated direction both are same, that means the displacement is like this direction, the force direction is like direction, that the acceleration direction is always to the opposite in direction. In this case also acceleration in this direction, but the displacement is moving like this direction. They are always in the opposite in the direction. That is the very important. Now we will move on to this one. Let me move on to this another case. Yes. Here in our present case, what is the acceleration of this point? So the direction of the acceleration is acting towards to the center, but the displacement is having like the center, like this, from mean position to the maximum position. It is the displacement direction, it is the acceleration point direction. In this case also the displacement direction is like this direction, but the acceleration direction is like this direction. So the acceleration is always act towards to the mean position. This is the acceleration direction, it is the displacement direction, this is the displacement direction. So they are always into the opposite in direction with the direction of the acceleration and the displacement, always they are in the opposite in direction. Let me move on to the another physical quantity in the simple harmonic motion. So that means if the particle is completing one complete revolution, so the particle is completing one revolution, that means the particle can execute one complete oscillation. So let me explain here. So now this is the reference circuit. So the particle is started here. So if the particle is started, it is completed one complete revolution. So the complete revolution means that means the particle is completed one oscillation. How it will be means? So the projection of the particle at this position is here. After if the particle is moving, the projection is here. After this particle is coming, the projection is here. After the coming to the position, the particle is here. After the particle is here, the position is here. That means will you please check the position of the projection of the particle, how it look like? Means it is started from here, it is moving up and coming down, and also it is going down and are coming in the same position. That means it is completed one complete oscillation. Complete oscillation means it is started, how it is started in the same direction, finally it will reach to the same position. That is, it is completed one complete revolution. So the time period is nothing but to complete one complete oscillation, what is the time is taken, that is named as the time period of the oscillation. Let me write the definition of the time period of the oscillation. That is also one important parameter in this one. So let me take the time period.
So it will denoted with capital T. Capital T time period means the time taken by the particle to complete one oscillation is called so that is called time period of the particle. So how much time is taken? What is the how can you find out the time period? So we in the kinematics we have the one special formula. So the one simple formula, velocity is equal to displacement time only. When the displacement time is equal to displacement by velocity only. But in our case we are in the angular velocity. The particle is in the angular. So that means the time period T is equal to in the oscillation is equal to, instead of S is equal to angular displacement divided by V is equal to angular velocity. Are you getting or not? Hello?
Sir.
So that means will you please look on this our present discussion. So the particle is moving like this. So that means if the particle where it is started, the particle is started here. So if the particle is started here, it is going on like this and it is completed one complete revolution. That means how much angle it will completed? So if it is moving like this and it is coming to the same position means how much angle? So it is completed 2 pi radians. That means the angular displacement is equal to pi divided by how much angular velocity. We are already discussing this one. The particle is having the angular velocity is equal to omega is the angular velocity. This is the formula for the time period of the particle in simple harmonic motion. Now one more formula is there. So you can check this one. Omega is equal to, what is the formula? Omega is equal to, let me take omega. No. V instead of in terms of V and omega. V maximum. You can take the V maximum.
Displacement.
No, not like that. Wait. Displacement and omega. Displacement and omega. Will you take the displacement and omega? Wait a minute, please. Wait a minute. Okay, how many formulas we have? 1 minute, ma'am. What are the displacement formula? Displacement formula y is equal to r sin omega t. We cannot do this one. Yes. Okay. We cannot do this one. No use. Velocity of the particle is equal to r omega. Only I am taking special case. R maximum is equal to r omega. Then omega is equal to V maximum divided by R. Okay na? Hello. Then V maximum formula. V formula. Tell me the V formula.
Root of r square minus y square.
R square minus y square. Na? This also we cannot apply. Wait a minute. Wait a minute. Okay. Let me write all formulas once together here. So y is equal to r sin omega t, one equation we got. So V is equal to what is the formula? R omega cos omega t, one equation we got. Acceleration A is equal to what is the formula? R omega square sin omega t we got. Sin omega t we got. This is the third equation we got. So my goal is to find out the relation between the V and omega. Now I am taking only magnitude. I am taking A magnitude. Here negative sign will indicate that A and displacement will in the opposite direction only. This will indicate. So if you take this one r omega square sin omega t, let me take this is the fourth equation. Now with help of this equation, if we divide this equation 1 divided by 4, so 1 divided by 4 means 1 divided by 4 is equal to y by a is equal to, so just I am taking magnitude, nothing direction I am taking. So and then r sin omega t divided by r omega square sin omega t we got. Sin omega t cancel, r cancelled. Then I am taking omega square on one side. So then omega square cross multiply, everything cross multiplied. So if we take like this cross multiplied means omega square means a by omega we got. So a by omega we got. Then omega is equal to square root of a by y we got. So this is the condition. So the relation of the angular velocity in terms of the angular acceleration and angular displacement. With help of this one we can easily find out. This is also important formula only. Now what where we stopped? Where we stopped?
T is equal to 2 pi by omega.
Yes. This t is equal to 2 pi by omega we start. So then can we write the time period of the particle t is equal to then 2 pi by omega we have the formula. Just to substitute the 2 pi into divided by square root of a by y is there. Then can we write like this 2 pi into square root of y by a. Okay na? No issue na? Hello, no issue na? Then t is equal to 2 pi into write this equation y by a. So this is also one important equation. The time period we can find out the time period with help of the displacement of the particle and acceleration of the particle. With help of this one we can easily find out this one. Now let me move on to the another important physical quantity, frequency of the particle. What does it mean, frequency? It is the number of oscillations made in unit time. So the number of vibrations, the number of oscillations, the number of oscillations made in unit time by the vibrating particle, So that is the frequency. So what is the mathematical expression for the frequency? The mathematical expression frequency neta will having, so n will take, n is equal to 1 by t, that it is the reciprocal of the time period. Then the frequency n is equal to 1 by neta means 1 by 2 pi into square root of y by a we can write. Otherwise we can take this formula can be write neta is equal to 1 by 2 pi into square root of a by y. This is the frequency formula. So the frequency formula. What are the units for frequency? Hertz. The units of the frequency is the hertz. That is the units for the frequency is the hertz. Now one of the special quantity we are going to introduce.